So we're writing in slope, intercept, form from a graph, a table, or a scenario. So slope-intercept form looks like this. Y equals mx plus b. So basically, we're going to leave the y and the x as y and x because we need those in there, okay? And we're going to plug in an m and a b. So that's what we need for slope-intercept form. We need an m and we need a b. We need a slope and we need a y-intercept. A slope, not slope, and a y-intercept. So this little prompt here tells us that we have a line whose slope is 5/2. Well, they're telling you the m, right? And then if they're saying that the y-intercept is 0, 3, what is the b value here that they're giving us? 3. So it'll be y equals, for the m, I'm going to plug in my 5/2. And then write the x, don't forget the x. And then add the 3. Can everybody see okay? If this is in your way, you can scoot to a seat where it's not like right in your way. Okay, and then here we have a graph. So this time we have to get the m and the b from the graph. So let's see if we can find some pretty points and find our slope. I see some pretty points right here. So what is happening here for my little slope triangle? What's my rise?
1.
Okay, my rise is 1, and my run is
2.
Good. So my slope is 1/2. And then what's my b value? -2. So my equation will be y equals 1/2 x minus 2. That's pretty easy, right? We can also get m and b from a table. Okay, notice that 0, 3. Okay, what's the y-intercept on this blue graph? It was 0, -2. Yep.
I got
What I want to draw your attention to is every time we have a y-intercept, pay attention to what the x-coordinate is. What is the x for each of these y-intercepts?
0.
0. So if we can find where the x value is 0, we can identify the y-intercept from a table. Do you guys see where the x is 0 in this table? Yeah. Yeah. So that gives us the point 0, 8, where the 8 is our b value. I'm going to write it up here. Okay, now we just have to find the slope. So let's look for the rise and the run. Where does the rise come from, the x's or the y's? The y's. So make sure you don't get it upside down. What's happening every time, going from 10 to 8 to 6 to 4? Subtracting 2. So I'll start my little m equals -2 over something. Let's find the run. Okay, it's adding 1 every time. So that just reduces to -2. So my equation will be -2x plus 8. Good. So we're doing the same thing, just in a bunch of different ways. Okay. We can have a word problem kind of graph. We've got Charlie saving $5 each week. He earned an extra $15 by mowing his neighbor's lawn. We have to write an equation in slope-intercept form for the situation and define our variables. Okay, the graph here, guys, is just to help us understand what's happening in this situation. We've got Charlie's money versus the weeks. Let's put the weeks down here on the x-axis. And we'll put the money on the y-axis.
Money earned.
Okay.
Saved. Money saved.
Money saved. So, week 0, when x is 0, he already has his $15 from mowing the neighbor's lawn, right? So for week 0, his money, his y value is already 15. Okay, how much is he saving every week?
5.
5. So after week 1, he's got the initial 15 plus 5 more.
20.
20. And then a week 2, he's got 25. So what do you think we should count by for the weeks? For the weeks 1s, for the money, probably 5s.
Mm-hmm.
Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, yada, yada. 0, 5, 10, 15, 20, 25, 30, 35, 40. That was a gross 40. All right, so he's starting at 15. And he's saving 5 every week. Boop, 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 boop. Do we have any indication that he stopped saving or does he continue to save? Okay, so we're going to give an arrow on the continues to save end, but no arrow on the starts at 15 end. So, looking at this, what pieces of information can we see? Like, do we have a slope? Okay, what is our slope? What's the M?
5/1.
5/1, so 5. And then do we have a B value? 15, good. And that came from the y-intercept 0, 15. So can we write an equation for this?
Yeah.
Yeah, what is it? Y equals,
5x plus 15.
good, 5x plus 15. So the last part of this says that we have to define our variables. Okay, that is talking about the x and the y. Okay, variables is not m and b. M is a coefficient and b is a constant. Neither of those are the variables. The variables are the x and the y. So, yeah, x is the weeks. And what's the y? Yeah, the money saved. So, did we really need this graph to do this problem? No, but it kind of helps us get a picture of what we're dealing with. All right, so this is the fun part. What is the domain for the function in this situation? So the domain is asking about what? Our x's or y's? X's. Okay, so that's the weeks. Now, our weeks start at what value? 0. And do they end or do they keep going because we put an arrow?
Keep going.
Okay, so the weeks start at 0 and keep going up forever. Perfect.
All x's.
Yes, so our domain will be all x values for weeks greater than 0. Can it be equal to 0?
Yeah.
Okay. Greater than or equal to 0. If you find yourself flip-flopping the symbol and just want to write out greater than 0, greater than or equal to 0, you can. That's fine. Okay. While we're at it, do you want to do the range too? Or right here, we might as well. What is the lowest value for the money that we've got? Yeah. So the y values are going from 15 and up, do they stop? No.
From
So-
15 to infinity and beyond.
For 15 to infinity and beyond. So if we want to do the range, it would be all the y values,
Greater than or equal.
which is the money greater than or equal to 15. Good. Oh, you guys are going to be good at this. I know it was a little painful in Unit 3 to learn this domain and range stuff, but you're already ahead of the game. Good job. All right, sweet. We've got a department store that offers a frequent buyer's card to let customers earn rewards on purchases. Each transaction is worth 12 points, and customers automatically earn 25 points when they sign up. Okay, so I'm a customer. Okay, I haven't even bought anything yet. How many points do I get just for signing up?
25.
Okay, so I've bought 0 purchases. Okay, but I already have 25 points just for signing up.
I already know the equation.
Okay, now I've made 1 purchase. How many points do I get?
12.
Okay, I'm get 12 additional points, so a total of 37. That was a stupid looking 12. Okay, what about after my second purchase? How many will I have? 49. My third purchase? 61. I'm hoping you're right because I'm really bad at mental math. Okay,
I'm
okay.
not doing this in my head. I cannot.
Okay. So, can we write an equation for this?
Y equals 12x plus 25.
All right. That was very confident and very correct. So y equals 12x plus 25. Okay. Let's look at some of the key words that we used to set that up. Okay. It says each purchase or each transaction is worth 12. Do you see that because it had the per, each, or every, 12 had to get the x? Okay? There's no per, each, or every on the 25 because you're not going to sign up a bunch of times, right? You just sign up once. That's the constant. It doesn't get an x. All right, now we have to define the variables. So it's not talking about m and b. M is a coefficient, b is a constant. We want the x and the y. What does the x represent in this situation? This one's a little tricky. What are we counting over here with 0, 1, 2, and 3? Yeah, the purchases or transactions. Okay, what about the y's? What's the y?
20.
Yeah, it's the total points. Okay, what about a reasonable domain? So this time we don't have a picture, but we do have a table. So domain is still asking about the x values. Oops, I meant to be on my highlighter. Domain is still asking about the x's. So what can my x values be? Yeah. We want all the x's greater than or equal to 0. Now I have a question for you because this is something that we haven't talked a whole lot about. We did it a little bit with sequences. Can I have a 1.5 transaction?
No.
Can I have a 2 3/4 transaction?
No, it has to be either none or 1.
Yeah, you tell me.
I could
0 or
have
1.
like none or 1 or 2 or 3. Okay, there's a special word for these counting numbers.
Greater than or equal to.
They're called integers.
Mm.
So we can't have all of the in-betweenies. Okay, so we're going to, for the first time ever in a function, modify this x values and specify that we want the integers. Does that make sense to everybody? Because we don't want the in-betweenies, we just want the counting numbers. So the integers are all the counting numbers, 0 and their opposites. So if we say we want the integers that are greater than or equal to 0, that's exactly describes the set of numbers we want. Okay, cool. If a customer has 145 points, is it possible that he or she made 10 transactions?
Yes. Because you do 145 minus 25 and divide by 12.
Okay, well, let's plug it in. So they're asking us, is this possible? For 10 transactions, can we have 145 points? We don't know. We have to test it. Do you see that they're giving us an x and a y to plug into our equation? Okay, so let's plug those in and test. So the y is what?
145.
145. 12 times 10 plus 25. Okay, somebody tell me what 12 times 10 plus 25 is.
So 145.
Oh, 145. Okay, so they are equal. So, yes, 10 transactions plus the bonus, the sign-up bonus, gives us 145 points. So if we had gotten an equation that was not true, we would say no, because 10 transactions gives us this many points, not 145 points, right? Any questions? All right, flip. Okay, Stuco is having a bake sale fundraiser where they earn $6 for every pack of cookies. The expenses for the bake sale are $120. We had problems like this in Unit 1, right? Where we had expenses. What do we know about expenses?
Minus.
Yeah, they're negative. So we're going to start in the hole and try to earn our way out of the hole with money. So let's make a table. Okay, so we're starting with expenses. We've sold no cookies, no cookie packs. How much are we in the hole?
120.
Yeah, we're at negative 120. Okay, now we're going to start earning $6 for each pack of cookies we sell. So after one pack of cookies, we're a little bit out of the hole, but still kind of deep. So I'm getting negative 114. Is that what you guys got? After 2 packs of cookies, that would be negative 108. Am I doing this right? Okay, after 3 packs of cookies, we're getting closer to 0, negative 102, and so on. All right, go ahead and try to write an equation in slope-intercept form to model this situation. What is your B value? What is your M? Are you boys writing this down? Where's your notes?
I already did.
All right, so what did you get? Y equals, good, 6x minus 120. Okay, now we have to define those variables. So what is the X over here that we're counting 0, 1, 2, 3? Yeah. I was kind of hoping someone would say cookies so I could say individual cookies because it's not, but you were right. It was packs. So good job being right. Packs of cookies. Okay, it's making me hungry. What is the Y value? Yeah, the money earned. And this is, yep. Okay, any questions about that? All right, we're just going to finish this one up and then we will save the Chad problem for a warm-up on Thursday. Okay, give a reasonable domain for this situation. So look at your table. What are your X's telling you? What kinds of cookie packs can we have? Can we have negative cookie packs?
No.
Okay. Can we have in-betweeny cookie packs? Like, can we sell half a pack of cookies? I don't know who would buy that. Like, here's an open pack of cookies. It'd be weird, right? So maybe like the last one we did, just the integers. So we can say that the domain is all the X values that are integers. Okay. Which ones do we want? Greater than, less than, what? Greater than or equal to 0. Good. Would an input of negative 12 be possible? What is input, X or Y? X. So can we have X equals negative 12, question mark? No, why not? Yeah, we can't have negative 12 packs of cookies. No, we can't have negative 12 packs of cookies. That doesn't make sense. Okay, if the bake sale made $300, is it possible that they sold 30 packs of cookies?
No, they sold way more.
So 30, 330. Okay, so the 30 is the X, the Y is the 300. So let's plug those in. You guys are saying no, but I still have to test it for the video. So 300, does that equal 6 times 30 minus 120? Okay, I put the 300 in the Y spot and the 30 in the X spot. So what was 6 times 30? What was it?
Yeah, 180.
Okay, so 300 equals 180 minus 120. Well, 180 minus 120 is just 60, right? That's obviously not true. So you are correct. So no, 30 packs of cookies gets $60, not 300. Can you see what the mistake might have been right here? If I thought it was yes? If I didn't see that the expenses were minus and I thought it was plus, I might have thought this was true. Okay, we'll save Chad. Okay, the kids are gone. They're in their second hour. We're going to finish the video. So, we've got Chad here. Chad has a lean body mass of 120 pounds, and he's trying out for the wrestling team. He works out and he's eating right because he wants to increase his lean body mass by 5 pounds every month. So his goal is to reach a lean body mass of 145 pounds and maintain it. Okay, so we're going to write an equation in slope-intercept form to model this situation. But let's start with a little table, okay, of our x's and y's. So Chad is starting with a lean body mass of 120. So after no months, he's already at 120 pounds for lean body mass. After 1 month, okay, he's trying to increase by 5 pounds. So he's going to go up to 125. Every time he's adding 5 pounds. Okay, after 2 months, okay, he's added another 5 pounds, and now he's at 130. Okay, after 3, he's up to 135. So we have to write an equation in slope-intercept form to model this situation. So you can see that the y-intercept is this 0, 120, and the 120 is the b value. Okay, and the 5, what we're adding every time, is the m. So that would be y equals 5x plus 120. So starting at 120 pounds of lean mass and then adding 5 pounds after that. Now we have to define the variables. So what does x represent in this situation? X is the 0, the 1, the 2, the 3. Those are the months. Okay, y is the 120, 125, 130, 135. That's the lean body mass. Okay, now we have to graph it. Okay, so I'm going to put my my months down on the x-axis. Down here, months. Okay, and we'll put lean body mass on the y-axis. And for a title, we can say lean body mass versus months. All right, so it looks to me like I'm counting x's by ones because I'm going 0, 1, 2, 3, yada, yada. So I'm going to do 0, 1, 2, 3, 4, 5. Just counting on my x-axis by ones. Okay. For my y-axis, it looks like I should count by maybe 5s. 5s look good. So I'm going to do a trick that I'm going to show you. I'm going to count by 5s, but I'm only going to label the 10s, and it'll make my graph look a little bit cleaner. So here's 5, but I'm not going to write it. I'm going to skip to the 10 and write the 10. There's 15, but I'm going to skip over it and do 20, 30. It'll also save you time, too, because you won't have to write so many numbers. Whoops, I just skipped 110. Okay. So our friend Chad is starting at 120 pounds of lean body mass. That's like his muscles and his skeleton, right? And like lean connective tissue. And he's adding 5 pounds every month. So 1 month he's up to 125, and then 130, and then 135, and then 140, and then 145. Now, when he reaches a lean body mass of 145 pounds, he's going to want to maintain it. So that means he's going to stop. So we're not going to put arrows on this thing. This graph is going to start and stop. So for our reasonable domain, we want to look at our possible x values. It looks like our x values are going from, if I follow this down, 0 to 5. So my x's are going from 0 to 5. So for the domain, I'm going to say all x values, which are the months, from 0 to 5. Because after 5 months, he's going to stay at 145. He's not going to change. Like, this function is not going to apply anymore. That flat part does not have a slope of 5 anymore. Okay. Same thing for the range. Let's find where our y values are. Our y values are right here. Oops, I went too high. He starts at 120 and the highest he gets to is 145. He doesn't go past that. So for our range, we want all the y values which are his lean body masses from, what was that, 120 pounds to 145 pounds. That's it. That's all we have to do for Chad, I think. Yeah. All right. Bye.